Alright, so this first question asked how can we use the different principles to help us with finding the area of the triangle. So one idea that we could do is we could draw uh, a line down the middle here, and if we connect and make two rectangles, we could say that we have from here we have half of a 2 by 4, and we have from here we can see that we have half of a 1, 2, 3, 4, 5 of a 6 by 4 rectangle. So we have two rectangles and we've shaded half of each of those rectangles. So here we have 4 plus 12, which tells me that the area would be 16 square centimeters for this triangle. Okay, so that's one method that could be used. Another, and that would be using the idea of the additivity principle there. So we could also use the moving principle, and what I could do is if I take that top part, take this little triangle, I could shift it right here. So this would no longer exist. And then I could do the same thing right here where I shift and say I cut that top part off and move it down here. This would no longer exist. Now look at what I have. I have a 2 by 8 rectangle. And again, that's 16 square centimeters. So there are more than one way. I can use other aspects, especially if I have it gridded, to help me use the moving or the additivity principles to solve these problems. Okay, so that's the first part. Now the second part asks to actually go into exploring the area of a triangle and understanding base and height and what that means. So first thing you're asked is to measure the three sides of the triangle. So we're going to do this for each of them. And then which would be the easiest base and why. And then use segment tool to draw in the height. And then what would be the area and how do we calculate it. So if I want to find the measurement of any of the sides, I can use my distance or length tool. So I could click on a measurement. I can click on each of these sides and say, okay, I know the length of each of these parts. So if I was going to ask myself, which of those three sides is the easiest to use to find the area of this triangle? It doesn't have to do with its location, it has to do with its measurement. Which is the easiest to measure? Which could I measure without actually having to use the measuring tool built into GeoGebra? And in this case, it would be segment AB. That would be my easiest side to use for my base. Not because it's the quote-unquote bottom, but because it's the easiest to measure. Because that 7 and 6200ths is an approximation. That 3 and 6100ths is an approximation based on the number of digits that I told GeoGebra to allow for measurement. Now, the next part would be, well, what would be the corresponding height? Well, if I do the height for segment AB, so I want to find the height that matches up with this segment here. Okay, so what I would do, I know that height is going to go, it's going to be the perpendicular distance from segment AB to the vertex that's not there, which is C. And what's kind of funky about this one is that it actually falls outside the triangle technically. So we have to think about our base as being a line versus being just a ray. So if I was to draw it, what I could really look at is this idea. I'm going to move this out of the way. That you see here that like AB, I've got this magic part here that kind of extends out because it's technically falling on the same line as what segment AB is located. And then I'd want that vertical height. Now look, well, that's easy to measure as well in here. And I can see that that would be 1, 2, 3 units, or I could use my my distance and length tool and see that that's 3 units here. So I think about, well, how do I find the area of my height? I know that area is 1/2 the length of my base times the length of my height. So 1/2 of 5 times 3 is 7.5. Now it's not the only way that I can find it, but it is one of the ways. So I'm going to hide that. Okay. I could use any of these other segments to actually find the height and find the area. So if I wanted to say use segment AC, well, if I drew in the height, it'd be a perpendicular distance from point B to segment AC. So I could use my perpendicular line and see, okay, that's where it should come, and I can verify it. I want to be the height to AC. You can see that's exactly where I need it to be. So I'm going to delete this out of the way just so it's not confusing. So if I wanted to find the area, I could do distance or length, measure that. So that's 1 in 97 hundredths. And again, these are approximations that I'm dealing with. So if I do 1/2 of 7 and 62 hundredths times 1 and 97 hundredths, I get 7 and 5,057 10,000ths. And that's, again, an approximation because of the rounding, but it's still right there at 7.5. So one of the reasons we want to try to use those whole unit sides is because it gives us the actual exact answer versus the decimals, which are very approximate. The same thing could be done with a 3 and 61 hundredths inside BC. So if I want to think about, well, what's perpendicular, this one's a little bit kind of funny looking as well. And if I draw in the height for segment BC, I want to be perpendicular to A. So I'm going to be coming straight down here. And it looks a little weird, again, but there is that height. And I could, again, measure it. And that's 4 and 16 hundredths. So if I did 1/2 times 4 and 16 hundredths times 3 and 61 hundredths, I get 7 and 5,088 10,000ths. So I'm within 1/100th of what the accurate answer is, and again, it has to do with my decimal approximations. So what I want to try to do when I'm finding the base and height, especially when it is gridded, is I want to find the sides that give me the whole numbers. So when I look at triangle DEF, if I was to measure these sides, or the sides that are very easy to measure, like DEF, I can count that by the boxes. That's 3 centimeters. Now if I look at side DF or FE, I can do my measurements here. DF and FE, you can see that, again, they're approximations. They are not easy to find. I can find them using things like Pythagorean theorem because of it being gridded and that being the hypotenuse of a right triangle that is imaginarily there. But that's still not an approximate answer. So I'd want to focus on trying to use the side that's very easy to count based on the grid for my base. So the best base I have here would be segment DE. So then I'll think about, well, what's the height? Well, I know that that's going to be perpendicular to the side that I'm using for my base and go through the opposite vertex. So that would be point F, and I want to go through segment DE, and there I can see where my height is, and I can even count it. And that's 1, 2, 3 boxes. And I'm going to just I'm going to undo that. I'm going to show you that, again, if I just drew it in here, and I use my segment tool to do or my distance tool, I can see that's 3 units. So that would tell me that the area of this triangle is 4.5 cubic centimeters. So again, I could find it with the others if I find the height and then do 1/2 the base times the height. So I could use 1/2 of 3 and 16 hundredths times the height created from segment DF to point E. But again, it's an approximation because of the way it's measured. I want to turn this off. All right, so now we get to our last triangle here. So before I even measure the sides, and I want to think about which side would be the easiest to measure the base. Would it be GH, HI, or GI? Well, if I look at GH is going this diagonal. It's kind of hard to measure what's going on there. It's kind of hard to measure what's going on here, but here look at HI. I can count that pretty quickly and see that that's 2 units. So that would be the side I would want to use for my base, because I would know pretty quickly that it has a base of 2. Now the question comes into the idea of, well, how do I get my height? Because it's way over. And I have to remember, think about the fact that I have a perpendicular, I got to be perpendicular to the opposite point. So think about this as, instead of being a segment, think about HI as if it was a line. And I want to be perpendicular to that line through point G. So I can click on G, click on that line, and there I can count my boxes as to what exactly would be that height, which would be right here. And that would be 3 units. And I can show that as well. So show the height for segment HI. There's that height. And again, if I wanted to measure it, I can come here to measure distance and see if that was 3 units. So I could tell if this triangle would be area of 2.5 square centimeters. So if I go up here and just look at some of the other things that were asked, they want to know for how to calculate it. Would it be easy? As you can see, hopefully, it wouldn't be easy to calculate these other heights without that centimeter tool that's given to us by D2L. We'd really be using the Pythagorean theorem to find that height, and it'd be in a square root, so it'd be an irrational number. So everything we always create would be an improper fraction. It'd be it would be a decimal that is irrational and goes on forever. So we have issues of always never being able to fully get the exact value. But we know that if we did, we could get very, very close to that exact value. But we want to try, if we ever have grids, to use the base and the height that are the most easy to use within the grid. Whether that is any side, it doesn't matter. Just choose the side that's the easiest to create that base and height measurement.